Hello? Okay, so good morning, everyone. Let's start our lab today. And today our lab is quite easy. Okay, there is not a lot of content. We could finish it faster. And it's mainly about model comparison. So usually we will compare some different models and then choose the best one for some certain tasks. Okay, so firstly, please download the notebook from the OLE and also upload the file, the dataset that we are going to use today, the CSV dataset. Okay. So as usual, we should first import some packages that we are going to use today. Okay. And still we are using sklearn or the machine learning method we talked about in our class. In our lab is based on sklearn. And later in neural network, we might introduce like PyTorch and Keras. But for conventional machine learning method, the statistical based method, we are using sklearn. Okay. And then we should prepare the data set first. Okay. So I think you're already very familiar with these things. So if you look at this CSV data set, we don't have open the data set. Let's see. In this data set, we have 1, 2, 3, 4, 5, 6, 8. 8 features. Okay. The first 8 columns are the features we have. And then we also have a target value. This is the label. Indicates if the patient, or if the participant has diabetes or not. Okay, and you can see we don't have the name of the columns in this data set, right? This happened before several weeks ago in some data set also, that we need to put the name of the columns. Here, we can define the name of the columns. And then we read the data set. Okay, so we just put the name of the data set. Oh no, okay. Because we already defined the file name. So we don't need to copy paste the name again. Okay. And the names equal to this is the column names. Okay. So put column names. We define the column names first. Also, for further use of this file name, we can define the file name as a variable, and then we use the variable in the readCSV function. Okay. And then we just put like the data we want to use. For training data, we need the features. So the features, we have, how many columns? 8 columns, right? 3, 4, 5, 6, 7, 8. Yeah, 8 columns. Okay. 8 columns. So the first argument here is the rows. So we want all the data, so we just omit it, okay? And then we put 0 to 8. 8 row or 8 columns. And also for the target value, the label is the last column, the 8th column, okay? And also we take all the samples from the rows, so we just omit it. And then we load the data set. And then we get the X value and the Y values we want. Okay. And then we need to define the model. So we can create a list of models. Okay, so let's say we want to test 3 different models that we learned in the class. Okay, the first one is the logistic regression, and then key nearest neighbors, and then naive Bayes. And yeah, so these are all for classification tasks. Okay. And you will see some parameters in these functions, like logistic regression. We have a solver. This is just like the choose of optimizer. Okay. If you are interested in it, you can have a look by yourself. Okay. So it's quite difficult to explain how this solver works. Maybe take a long time to explain. So if you are interested in these kind of parameters, you can have a look by yourself about mathematical things. Okay. And then we just run this cell. Yeah. We got a list of model. Okay. And then in this list, we will have check if I can. Yeah, in this list, we have 3 tuples. Okay. This is the first tuple. And this second tuple. Third tuple. In each tuple, we have the name of the model. Okay. Tuple is just like a group of data with different group of data, but can be in different format. Okay. So that's why we have data of string and data of a model. Okay. So like this is the string of the name of the model. And then this is the model we are going to train. Okay, so if there are 3 tuples, which has their corresponding name and the model. Okay. Then here we want to evaluate all the models. Okay, we create an array to store the results. And also we create an array to store the name. Okay. And then we put the performance metric as accuracy. We use the accuracy to check the performance of the model. Okay, and this k-fold we've imported from the library. This is like for cross-validation we've talked about before. So k-fold means how many validation, how many folds of the data set we are going to use. So let's say if we put 10, then it will be a 10-fold cross-validation. We will split the data into 10 different sub-data sets. Like 10 split. Number of split. Okay. We split the data set into 10 different sub-data sets. Okay, and then we evaluate the model for 10 times. In each time, we evaluate with a different subset, and the remaining 9 subsets we use as finite. Okay, and then we just put the arguments for this function. This is to get the result of the cross validation. Okay. Model, and then the variables, I mean the input of the model, X and Y. And then CV cross validation, we put key fold, right? Okay. Cross validation, we put key fold. And then SUI, scoring SUI. What we put scoring equal to scoring. So this is the cross validation of the model. Okay, and then after in each iteration, let me explain this iteration in this loop. Okay, so in each iteration, we get the name and the model in the models. Okay, so it's like we get the first tuple and the second tuple. Oh, not here. Wait, I did it. So in each iteration, we will process one element in the list. So it will be a tuple. And in this tuple, we have two elements. One is the name, one is the model. Okay, so for the name and the model in the models. Okay, so how this iteration work. And then when we do like this, we will directly give the variable of the first tuple, first element in the first tuple to name, and the second element in the tuple to model. Okay. And then we copy the results and put the results in the result array. Okay. And also we put the name of each model in the names array. Okay. And then we just print the results out. Right. Yeah. So then we have, for each model, we have two kinds of result. One is the accuracy. Okay. And based on this accuracy, we also calculate the standard deviation, because sometimes, or usually, we want the model to have a stable performance for different data. Okay, so usually, if the standard deviation is too big, it will be not good. Okay, so we can see in our result, we have similar standard deviation for the three different models. Okay, so standard deviation is the square root of the variance. Okay, so it means the data has small variance, which is around 5%. Okay, 0.05 means 5%. And this accuracy, for example, this one is like 77.6%, right? Okay. So this is the result we got. Then we can also have a more detailed view of this result with a box plot. Okay, very simple. Actually, yeah, the codes are all provided. Yeah, so here is a box plot for different models. And like for our logistic regression, we test this logistic regression on quite a lot of data, okay? And then, we test it on, yeah, we test it for 10 times, right? I think this is the average here. 77. Okay, yeah. And then, yeah, the box plot means give you 5 points of data, okay? So we can see we have like 1, 2, 3, 4, 5 edge. 5 different lines in this plot. And then the highest part represent for the maximum value, okay? And then the lowest part means the lowest value. And then this is the first quarter. This is the second quarter, the third quarter, okay? And second quarter is actually means half, right? So this is the median value of the performance of the model. Okay, this is the median value. And this is the first quarter. This is the third quarter or the last quarter. Okay. So let me explain again in Chinese. Okay，这个是象限图。象限图里面有2元素，首先是最大值，然后还有最小值。然后这个黄色的是那个中值，median value，中文。中位数，对，中位数。然后这个是中位数，然后是这个是上1/3，上1/4区间，还有下1/4区间。对，这个和那个中位数的概念差不多，但是它指的是上1/4和下1/4。Okay. So with this box plot, you'll be able to know the distribution of the data. Okay. So like the variance, the difference between the maximum and the lowest value, and also sometimes there will be some outliers. Okay. Let me check. Box plot. Outliers. Okay. Like this figure. Sometimes there will be some outliers. So means the distribution of the outliers is very different with the majority data. Okay. And then they will treat it as an outlier. Probably there will be some noisy data. Okay. So they will just ignore this data and then give the distribution for the majority data. Okay. So this is how we do box plot. Yeah. And we still have quite a lot of time. So I want to introduce another way to do this model comparison. Okay. So let's say here we are using a tuple. Okay. But I think in a more popular way. Okay. Usually we can create a dictionary, right? I think you are very familiar with dictionary. Usually we can do like this. We can put like the key, right, of the name of the model, and then the value of the dictionary to put the model. Okay. This is another way. And like this. Okay. And then we can see, can put another key and its value of another model. Okay, this is not the homework. Okay, so just because we have a lot of time. So the last one. Okay, so model. Okay, let's create a model dictionary. Okay, so the use of it will be very similar to the tuple created here. But the advantage of a dictionary is that if we want to find a model with a specific name, we just need to use the name of the model. So it will be very efficient to find this model. Okay. However, in a tuple like here, if we want to find the, let's say, the Gaussian naive Bayes, okay, we need to do a loop of iteration. We need to find one by one. We need to check from the beginning of the list one by one until we find this model, okay? But in the dictionary, if we want to find this model, we can directly find it by the key value of the dictionary, okay? So this is why dictionary is more efficient in the grid. And then we can also use the loop. But I think we can first paste here. Okay. And then we need to do like, the only thing we need to change is that we need to put model.items. Item. Item. Yeah. Check. We can just do like this. Oh, sorry, I forgot to change this one. Okay, yeah. Now we are using dictionary. Yeah, and then the result will be the same. Okay. Yeah. So this is another way. Okay. Let me put down. Go down, down. Okay. And also this one down, down. Okay. Yeah. Okay. So here we have two methods. Okay. The first one is like we create list. The second one we use is like we create a dictionary. Okay, they are very similar. The only difference is like when you're doing iteration for the dictionary, you need to put dot items to find the items in the dictionary. Okay. But for the list, we don't. Okay. How we use dictionary to do model comparison. Yeah. And we still have 20 minutes left. You can work on your exercise today. Oh, there are a lot of exercises today. So I'll give you 20 minutes to try to finish it. And if you have any questions, please let me know. And here you can check the result by just type the results here, okay? Because we didn't show all the results in this box plot. And if you just print the result, you can see we have 10 results for each model, okay? And then here we just print the average accuracy. Yeah, we are printing the mean value of the accuracy. So we've got 10 results for the cross validation. And then here we calculate the mean value of each model as the performance, okay? And also then here we plot the box plot with all the accuracies we got from different validation data sets, okay? And let's say, for example, in the linear logistic regression, in this 10 cross validation, actually we have quite big difference in different cross validation. I think it's because the data set is not big enough. For example, we have only 700 samples. So if we split into 10 subsets, for each subset we only have 70 samples. Okay. So there will be a big difference in the results. Sometimes we got only 68 accuracy, and in some other data sets, or in some other validation data set, we got 80% accuracy. Or the maximum is like 84% accuracy. So there's a 16% difference. I can see this difference in this box plot. Okay. And if we change it to 5, we change this to 5. Yeah, then you can see there'll be some outliers because most of the data are around like 75%. And there's an accuracy which is over 82%. So it is treated as outlier. Right? It's not very meaningful if we're using box plot and we only have 5 samples. Okay, it's not a very practical way. Usually we will have like much more than 5 samples to use box plots. looks like a escalator step. Uh, okay. I'm not sure if you know about the. I think we've done these things in previous lab about how to load dataset from sklearn. Okay, so you can just import. Where is this? From sklearn import dataset. Okay, datasets. And load the, we should load this dataset. Okay, so load breast data cancer here. Copy paste this. You can check this online. Okay. So we see like breast, yeah, perspective, breast. Okay, let's put like something like breast cancer data equal to data sets dot load breast cancer. Okay. And this was done in previous labs, I think. Breast. Just in case you forgot. Okay, let me mention it again. This should be. Then we need to do slicing operation. Okay, so how many rows we want? Plus 200 rows, right? And y, how many rows? For data relation later, x and y. Okay, only the first row. Use only the first 200 rows of data for evaluation later. This part of data. How the data looks like. What the dimension pictures. One code. Oh, okay, okay, okay. So you use all the data, all the 200 rows for evaluation. Right. Oh, I need to do like the data inside. Okay, yeah, like this. Data in the data set, and then the first 200 rows. Okay, that is how you get the data. But Oh, wait. Yeah, this is target. It is kept two things. Okay, target. And the X, the data part is all features. Yeah, I was like, where's the target value? Okay, and what the target value looks like. Well, yeah, the target value is similar with the diabetes one. Okay, it's like 0 indicate if it has a cancer. A 0 it means no cancer. 1 means has cancer. That makes sense. Target, yeah. So it's like here. Okay. So for all this library in different framework, you can check online like how to use these kind of functions. Let's say here, you can see it returns a data and target. Okay, tuple data and target. The data is the feature part. The target is the label part. Okay, so that's why we put X as the data part and then Y as the target part. So it is a bit different with what we used before. Because here we do the slicing of the target and the features manually. Okay, but here when you call this data set, it will return you a tuple of these features and the target. So you can directly use the dot data and dot target to use the features and the labels. Okay. And the following parts are all the same, I think, with the things we've done in the lab. So I think you will be able to deal with. Okay, then, yeah, it's the end of this class. And thank you very much. See you next week.